Okay, let us see now I from road or ladder. When you hear one non-uniform ladder, it means that the weight or the center of gravity is not acting in the middle of that ladder or road. So meaning, always if we have a uniform road, it means that the center of gravity and the weight are acting in the middle. If it's not uniform, then it means it's not acting in the middle. Okay. A non-uniform ladder, AB of weight 98 newtons and 10 meters long, is in limiting equilibrium. When we are limiting equilibrium, it means that friction is at its maximum. At an angle of 60 degrees to the horizontal, with its upper end A resting on a smooth but all smooth, there is no friction. And lower end B resting on a rough horizontal floor, rough friction. If the center of gravity of the ladder is 4 meters from A, now they are telling us that our ladder, the center of gravity, is 4 meters from a point. It means that now the weight is also going to act at that point, 4 meters from A. Where the center of gravity acts, even the weight is there. 4 meters from A, find the long reaction at A and B, and then the coefficient of friction. So we start with a sketch. So, in our solution, this is going to be our sketch. So that's going to be the vertical horizontal flow. So I'm going to be having, this is going to be my ladder, A, B. So this is A, this is going to be my B. Its upper end A resting on a smooth wall. First of all, is there a contact? Yes. Here and here. So what happens if there is contact? There is a reaction. So reaction at A, then reaction at B. Reaction at B. First of all, that's it. Do you have the length of the ladder? Yes. It's 10 meters long. So from there up there, I have 10 meters. Do you have the weight? Now this time they are giving us weight. So we shall reach at that. There's a limiting equilibrium with an angle 60 degrees to the horizontal. So 60 degrees to the horizontal. That's the first thing. Okay. Now they are telling us that if the center of gravity of the ladder is 4 meters from A, 4 meters, so if we move 4 meters from A, I think this is my 4 meters are going to be somewhere there from A. So if these are 4 meters, it means that the balance is going to be 6 meters because the wall is 10. So if this is where the center of gravity is, even the weight of that ladder is going to act there. That's why now I'm going to be having my weight here as 98 newtons. Now this is weight, it's not mass. If it was mass, then I multiply with gravity. But they are giving us weight. Always be careful. Now some questions they will say it's 2 over 3 from, it's 2 over 3 of the length. You get 2 over 3 times the length, then you put there your center of gravity. So those are the some common cases we can have. So that's the idea. Now they're telling me that, remember this is rough. If it's rough, in terms of sliding, it's going to go this side. It's limiting equilibrium means friction is at its maximum. So it's our friction, remember, is equal to mu R. So meaning, if it's about slide, it's going to slide going that. Of course, it can slide going upwards. No? In normal case, it's going to slide going this side. So friction now is going to be opposite the direction, this one. So my F, friction at B, that's given by mu R. Mu R, but this reaction here is B. That is the case. So we are done with almost everything. Now the part is to find the reaction at A and B. What are you going to do? We are going to first resolve vertically. So if you resolve vertically, you see that what do we have vertically? We have RB equaling to 98 newtons. So we have the reaction at B. As simple as that. We have the reaction at B. Okay. So we need also this so that we can get that. So let us resolve horizontally. resolve horizontally, we have first of all RA. This is the ordinary horizontal force going in that direction is equal to this. Why is it equal? Because it's limiting equilibrium. So you can call this FB is equal to FB. I call this my equation 1. So what do we need now? So that I have RB here, but I don't have this here. So I can't get this now. Means that I'm going to take now moments. Now you see here we have A, we have B. The question is, where can we take moments from so that the solution is simplified? You see this one, we have only one force, and here we have two forces. So it's always better to take our moments where we have many forces. And the other thing is, you see here, for this force, if you take moments here, you can easily determine this perpendicular distance from here up to here, than determining it from here up to this. You can, but it's a bit, this is simpler to determine that distance. So that's why we take moments at B. So taking moments at B anti-clockwise, you can take them clockwise, no problem. Now anti-clockwise, now, if you take moments at B, it means that all the forces from B are going to have 0 moment. Why? Because at this point, remember moment is given by the force and the perpendicular distance. So if the force is from here, it has no perpendicular distance from B. So from where we are taking moments from, there is no perpendicular distance there. That's why here is the same as this. The moment of this force coming from here is going to be 0, and this one is going to be 0. So the only forces which are going to survive are this and that. Those are the only forces which are going to survive. So we are taking more moments for these two only. So take the moments at B anti-clockwise, which the force is acting anti-clockwise. See that we have this one. You see, it's acting anti-clockwise in that sense, as you can see, anti-clockwise. Okay? So we have this, but we need this perpendicular distance from here up to here. So what happens there? So now we draw a simple right arm triangle, and we can get its perpendicular distance. Okay, now I need for this, remember this force is vertical. So this one is 6 meters. I have this as 60 degrees. So, you know this is the distance. Now I can get this because I need from here up to here. You know this is adjacent, it's going to be cos. So this is going to be 6. Now cos of 60 degrees, which will be 3 meters. Because cos 60 is a half. Then, they want, but they don't want this because we want the perpendicular distance, this perpendicular distance from B, I think we see from here up to here. So we have the longest side, the hypotenuse, from here up to here, then we can get this. Okay, so there I'm going to be having now 9 newtons, now times perpendicular distance, which is 6 cos 60. It's going to be equal to 2. Now we have our this force. This one now is acting clockwise. I think we can see. Now we need the distance, perpendicular distance from B. Now this is the, you know this force is the horizontal. So this perpendicular distance has to act vertically. So now I need the distance from here up to here. So you see, from here now up to here, it means that I'm going to use this. Remember, I have for the whole from here up to here, I have it as 10. So meaning, if I consider this now, if this is my 60 degrees, now from here up to here, this is our A, B. This is 10 meters. I need this, so this one is going to be 10. You see this is opposite, sine 60 degrees with ease. I don't need it because this is horizontal, so its perpendicular distance has to be vertical. This was vertical, its perpendicular distance has to be horizontal, that's why we consider that. Okay, so now I say I have RA, then times its perpendicular distance now is from here up to here. This is going to be the opposite. This is going to be 10 now, sine 60 meters with ease. So 10 sine 60 meters, as simple as that. So from here I think we can every determine our, so this is going to be 9/8 cos 60 is a half equal to RA times 10 times cos sine 60 is equal to 3/2. From there, we can every determine our RA. So our RA is going to be 9/8 times 3, or this is going to give us a half, divided by DC 10. This is going to be 5√3. So the answer here is 33.9482. So this is the reaction at A. If I have a reaction at A, so you can easily get our friction force. So, but what is our reaction at B? We had already our reaction at B here. So I have reaction at A, I have reaction at B. So part A is done. So let me come at part B. I want to get the coefficient of friction. So you see from 1, we say that our RA is equal to FB, which is going to be equal to our RA, 33.9482 newtons. So therefore, our friction force B is 33.9482 newtons. But we need the coefficient of friction. So we are going to use now this. But our FB is that our FB is mu RB. So it's going to be equal to 33.482. So our mu is what we are looking for. Our RB is what? It's 98 equal to 33.9482. That our mu, the coefficient of friction, over 98. So our mu from here is going to be it's giving me 0.3464. Has no units, and that would be our answer. So that's how we handle that. That's how we handle cases when we have non-uniform rods. They will always tell you where the weight is going to act from where to where, or they can give you the center of gravity of that ladder or rod. That's it. I wish you well.